right, welcome back. So far in our void loop, we have an analog read that reads the value on A0 where the potentiometer is plugged in at. It stores that value in pop val and then prints it on the screen, and then loops back through and does it again. Reads, stores, prints. Reads, stores, prints, reads, stores, prints. It does that hundreds of times a second. We can see on the serial monitor how quickly it updates. Now, the serial monitor isn't keeping up with the Arduino, so it's actually happening much faster than that. Let's see, what else? In doing so, we had to open, remember this line of code here, the serial begin, opens a serial connection between our laptop and Arduino so we can pass that data back and forth. And then we have to, whenever we're using a pin on the Arduino, we need to tell the Arduino whether it's going to be an input or an output. So pin mode does that. You tell it which pin, and then you type here the word either input or output. And we'll see that later. All right, today we're going to have to now turn our attention to the brushless motor. We want to be able to make that motor spin based on the values from the potentiometer. To use the brushless motor, we're going to need to bring in a library. So we talked earlier about what a library is, and it's this chunk of code that someone else has written to solve some problem. In this case, getting motors to spin properly. They've done all the work to figure out how to make that work well, and then they've put that code, they package it up into what's called a library. Let's go ahead and see if we can find it. So I do notice down here on my line 15, I put a parenthesis. It should be a 0 instead. It looks like I did that again here. Looks like I'm holding the shift too long. All right. You clean up your code errors, I'll clean up mine. Although it doesn't really matter because it's inside of a comment. All right, so first thing I'm gonna do is come over here to the libraries, and I'm gonna search for a library called servo. Servo motors are a special type of motor that twists usually between 0 and 180 degrees, 0 and 270, and sometimes they can twist all the way around. But what they do is they have they're very good at controlling exactly which way they're pointing. And they're used kind of just as a one turn kind of motor. It doesn't spin around like a wheel. They just turn and point towards something. So think of like a dial or something turning for like a speedometer to a certain place. And we're going to use this library called servo, and it actually can control brushless motors as well. There's someone's added code to it, so we're going to hit include here. When we do that, at the top of our project, it's going to put this #include. That's the library include command, and it's going to search for the library called servo.h. And then what it's going to do, I'm going to actually take this, I'm going to cut it, Control X, and drop it down below my description, Control V. Usually we put the servo call below this, but above the void setup. So it can't be in void setup or void loop. It needs to run before you get to those things. Awesome. So that's the library's been included. So now when we run our program, Arduino knows to go to the servo library and grab all the code and use it when it's building our program for us. If you're ever wondering how a library works, you can click on the more information. That'll open a window that'll take you through all the available commands and the different boards it's compatible with. These are different releases, overall usage, but down here is the really nice stuff. These are the methods. So these are all the different commands you can use. We're going to use write microseconds for our brushless motors to send commands to the ESCs. So all of these are terrific ones to use. You can take a look at them. We're going to also use attach and write microseconds, the two that we're going to use. All right, so back to it. And you can, if you click on them, you can actually read about exactly how to use that, what's called method. It's like a command or a servo or a function. You see here we need #include servo h. We have that. We need servo my servo. This is something that we're going to actually generate a name of our motor. So this servo is a command that says, hey, the name's coming next. And then here's what they named it. They named it my servo. It doesn't need to be named. It's going to be named anything. In the setup, you need to attach it. So you do the name of your servo. In this case, they called it my servo dot attach, and then the pin in which it's attached to, and then the void loop, you can control it. So these two things have to happen before you can control a servo motor. Let's get to them. So right here, we're going to come down here above setup. Actually, I'm going to do it above my variable as well, right below this include servo. And we're going to do capital S servo. And we're going to name the servo. I'm going to name mine practice motor. You can name yours whatever you want. So this names the motor. Now, whenever I want to spin this motor, I'm going to just call practice motor. All right, now in the void setup below, it doesn't matter where it is in void setup, I'm going to put mine above the serial begin, between the pin mode and serial begin. I'm going to just do practice motor, the name of the motor, dot. And if I double click on it, here's a quick trick. If I double click on it, it'll highlight the other names that are spelled the same. So if I'm wondering if I did a typo, I'll sometimes just double click on it and then see if it matches the one I did earlier. It doesn't matter if it's spelled right or wrong or anything. As long as it's spelled the same, you're okay. Dot attach. And we have ours attached in 3. Except I spelled attache. Dot attach 3 semicolon. Again, a semicolon at the end of the line. Notice here that the include command does not need a semicolon. It doesn't use one. Some things do, some things don't. All right, practice motor dot attach, although almost all things do. Usually the only things that don't are things that have an opening curly brace, because instead of ending the line, you're opening the void setup. And then things that begin with a hashtag like this as well. All right, so this tells Arduino where the motor's attached to. All right. So now we've included a servo library. We've set up the name of our servo motor. We've told it where it's attached at, pin 3 in this case. And now we need to go try and spin it maybe. So right now we have values in pop val that go from 0 to 1023. The motor speed values are weird. They range from 1100, which is full speed backwards, to 1900, which is full speed forward, and then 1500, which is off. Super strange numbers. I don't actually know the reason why they're those weird numbers, but those are the weird numbers. So 1500 is off, 1100 full speed backwards, 1900 full speed forward. So we sent these values straight from pop valve. We just sent those to the motor and said like 312, the motor would be like, I have no idea what we're talking about. Like full speed, it's just not in my range. So we need to learn a new function here that allows us to take one range of numbers, in this case 0 to 1023 that we're getting from the pop valve, and take those numbers and change them into a new range of numbers, in this case from 1500 to 1900. I think we'll start there. All right, that is called a map. That's called mapping. Mapping allows us to take one range of numbers and map it into another range. We need to give it 4 parameters for the mapping. Well, 5 parameters actually. The first thing is what you're mapping. Well, we're going to take our pop val data. So I'm going to put the variable called pop val there. Whatever number is stored in pop val. And then we need to tell it what range it's coming from, because it doesn't know what the starting range is. Well, the starting range is anywhere between 0 and 1023. And we want to map that to a new range of 1100, 1500, 1900. So for this first example, we're going to ignore the backwards direction for the motor. So we're going to say, hey, if the pop val reads 0, map that up to 1500. If the pop val is at 1023, map that up to 1900. And if the pop val is somewhere like 512 in the middle here, map that to a middle number between these two numbers. So again, the map function is just map parentheses the thing you're going to map, which in this case is the value stored in the pop val variable, the range it's starting in, so the high and low possibilities of where it starts, and then the range where you want it to end up. Now, put a semicolon into this. If we run it right now, what we're going to get is it's going to map it, but it's going to instantly forget it. Remember, the Arduino is crazy stupid. It's literal. So you've got to tell it where to store it, which means we need to make a new variable. So this new variable is going to be like our motor speed. So I'm going to call this mSpeed. And in computer programming, we have a way of naming that. It's a loose convention. It's called camel casing. You start the first word lowercase. Every word after that, you have uppercase. There are also some times when people will use underscores and not use caps at all. So m_speed is another way to separate words inside your variable. It just makes it more legible. I tend to use the camel casing method, but it doesn't really matter which one you use. Whatever you feel is the fastest to type. All right, so we've got this motor speed variable now, but we haven't actually created the variable, we just used it in our program. So we're gonna go back up to the top to our variables, and right below our pop val variable, we're gonna do an int, and we're gonna do mSpeed equal, and this is where we're gonna give it a starting value. We want our motor to probably start in the off position, so I'm gonna give it the off command, which is 1500 instead of 0. So your starting values won't always be zeros, whatever you think a good starting value will be. And then this is so it creates a mSpeed variable okay. And there's nothing special with these names, we're just inventing them. You could put Bob's uncle here, just wouldn't be very helpful to remembering long-term what it means. Although I'm sure some of you will use Bob's uncle now. All right, so this converts the pop val numbers into the motor speed range. From 0 to 0-1023 to the motor speed range of 1500 to 1900. All right. So now let's see if this works. So again, if we run this, we won't be able to see it because it's happening in memory. The way we check out memories, we use a serial print. So I'm actually going to click on the it doesn't work on this one. I'm going to highlight all of this row 20. Ooh, highlighting's a nuisance. Copy it and come down here to the bottom and paste it in. And let's see, instead of pop val, I'm going to want to print motor speed now. So here where it says pop val, I'm going to do mSpeed. And let's take a look at what that looks like. So I'm going to go ahead and plug my Arduino in and upload the program. Oh wait, before we do that, we should have done this at the very, very beginning. I totally forgot to do this. We need to rename our sketch. It's got this weird, crazy name to it. So rename, let's do motor and potentiometer. All right, so now it's named motor and potentiometer. That way we can find it easier. You've probably already found that it's difficult to find it when you give it a random name. I'm going to open the console up so I can see kind of what the progress is. You can see it's flashing through all its stuff. Turned green, everything's done. Hide that back again. I'm going to open the serial monitor. And we can kind of see what it's doing, but it's really hard to read because it's putting everything on a new line here. So let's go over some formatting stuff to make our lives easier for the serial monitor. Because they're right above and below each other, it's hard to tell what's happening. So what I'm going to do is I'm going to come back over here. I'm going to find my first serial print. I'm going to say, you know what? I don't actually want a new line right there anymore. I want the new line to happen after I print this so they're side by side. But if I do this now, they're going to be squished together and it's going to be hard to read still. So I'm going to do a few weird things. First of all, I'm going to create a new serial print up here. I'm going to create a line above this and put it right there. And in front of this, I'm going to put in quotation marks. I'm going to put this in quotation marks and then put an equal sign, space equals in there as well. So that's going to print, instead of printing the number stored in pop val, because I put quotation marks around it, it's going to print what's called the string or the actual name pop val. It's going to print this word on the screen, and then it's going to put this number behind it. So I'm going to do the same thing down here and open this up. And in front of this one, I'm going to put in M speed, so I know which one's which and which one's changing. And in front of this one, I'm going to put extra space. Otherwise, the M and M speed is going to be squished against the number from pop val. And I'll put a couple spaces so you can kind of see what that looks like. And then let's add some quick description here. Prints the word pop val. And this one, oh, it does not like to do that highlight across the screen. Prints the word M speed. All right, let me upload this. I'm actually going to close my library screen now so we can have a little more room to see. Okay. Sorry, it's being brutally slow today. I'm not sure what the holdup is. All right, so I finally got it to upload, and now when we open up the serial monitor, you should be able to see a much more readable run. And so sure, we have the pop val, which is the first serial print, the value from the potentiometer, M speed, the words M speed printed here, and then 1900, and there's those first couple spaces I put in front of M speed. That gives me some space between the 1023 and M speed. So you can just play around. It is literal. It's not going to help you by doing something logical. It's going to do exactly what you say. So if you don't put any spacing here, it's going to squish things together. It's just how it is. All right. So I'm going to turn the potentiometer, and I can see, ooh, awesome. So the pop value goes all the way down to 0 and it goes to 1500. That's that mapping that's happening there to convert those values on the fly. So it looks like everything's working perfectly, but the motor's not spinning. And that's okay because the motor won't spin until we plug a battery in. So our next step now is to get our wiring checked by an adult to make sure everything is wired in a safe way before we plug in one of our super powerful batteries. All right, welcome back. So what we're going to do now is this is our batteries. So they are a LiPo battery, which is an advanced battery technology that is able to produce lots and lots of energy really, really fast. So we have to be careful with these batteries not to mess with them. This cable here, you'll never use this. This is for when you're recharging the battery. It keeps track of the voltage of all the different cells so that it's safe to recharge, and it does so in a safe way. All right, so I'm going to plug this in now. I've had my wiring all checked and it's been determined to be safe. I'm going to plug this in. And that's the sound I'm looking for. I'm looking for that happy sound that comes on. That means the motor got going. So you notice though it's not moving. Like I'm sending a speed of 1900 to the motor. It should be spinning full speed forward. These motors have a safety feature built into them. So when they first turn on, they do not actually arm themselves, which means they allow themselves to spin until they get an off command. So to get this motor spinning, I'm going to actually have to first take the motor all the way down to 0. It should be armed now, so when I turn it on, oh, never mind. The motor shouldn't spin yet. What am I talking about? I'm going to unplug the battery. Boom. I got way ahead of myself. So if I go back to my code, if I look at my code, I actually haven't sent a command to turn the motor. I've just created this variable called mSpeed, but I haven't actually sent that speed to the motor. So that's the next step here. All right. So the command for this is the write microseconds command is what we're going to use for our brushless motors. So to figure out how this works, I'm going to go back to my library reference that I had opened before. This is the attach one. I want the write microseconds. So I'm going to go back real quick to the main servo library explanation. Click on write microseconds to see what the code looks like. And down here I'm noticing, okay, so you have to do name your servo. In the void setup, you need to do the attach and then the write microseconds 1500. So this will set a servo to the midpoint or a brushless motor to off. Now we're not going to actually do it quite this way, but here's the command. Name of the servo dot write microseconds, the speed you want to spin at. Let's go back and look at our program and see how we want to work that work. First of all, we're going to put this in the void loop because we want it to constantly update the motor speed every time through. If we put it in the void setup, it would run once and only once. So here we're going to do the name of our servo, which is practice motor. So on longer names like this, sometimes I'll just copy and paste the name instead of trying to retype it. It's a really common error to retype. In fact, let's throw some errors real quick. So you can see some errors being thrown. You probably have already thrown some errors. I'm going to intentionally misname this name of the motor. Dot. And I'm going to do write microseconds. And then in parentheses, I'm going to tell it how fast to spin. Well, how fast to spin is this value stored in motor speed. So I'm going to come up here and copy and paste the motor speed variable and put it in here. So that's the one thing you have to give the write microseconds command. You've got to give it the speed you want to go at. We don't need to tell it where to send the command because the practice motor is already attached up here at pin 3. So it already knows to send this command because it's the practice motor to pin 3. So we don't need to give that. And let's leave off our semicolon off this one and just see what it does. So I'm going to put a space. And then this sends the mSpeed value to the ESC. Okay, and then the ESC is going to handle making this all work. All right, let's upload this, open our serial monitor. That's kind of funny. I got ahead of myself there. All right, we had an error in the upload, which is weird. We'll just try it again. Sometimes trying it twice resolves the problem. Oh, what am I talking about? I have put errors in on purpose. Okay, so let's go find some errors. So up here, we're going to look through and read what's going on here. So this tells us where our file is. So you can look at all of this, and this is the motor and potentiometer file. Okay, well that makes sense. That's the one we're using. And then down here, read through this in function void loop. So that I know that I'm in my void loop. There's no errors up here I need to find. That's helpful. And I scan through this craziness. Precis motor was not declared in the scope. When you see it was not declared in the scope, it's almost always either you didn't make the variable at some point, or you've misspelled the variable at some point. In this case, it's the misspelling one. So I know to go back and look for that, and sure enough, there it is. Practice motor. If I double click on it, you can see now it's the same spelling. So that's awesome. I can upload this now. I think we built in one more error here. So we built in a semicolon error. Oh, yep, we threw an error again. So back up here to the top. This tells me which file I'm in. So here's all the location of that file, motor and potentiometer. The next thing it tells me it's in the void loop. That's good to know. And then error, expected a semicolon before this symbol. And that is... Yeah, so 27, it didn't hit this problem until it got to here because it hadn't seen a semicolon. So somewhere above the red line that's identifying there's a missing semicolon. If I look like, okay, there's not supposed to be one. Oh, there it is right there. There's supposed to be one right there. So that's error searching stuff. And let's take a look, see if that actually loads now. Maybe we get lucky. Yay! All right, now we should be ready for a battery. So I'm going to take my battery and plug it back in. Once you get your wires safety checked, you're good unless you change the wiring to keep plugging the battery in and out at that point. All right, so again, I'm sending a value. Oh, let me open a new serial monitor so we can see what values we're actually using. Okay, so right now we're sending a value of 1767 to the motor. But again, it won't spin until it gets an off value to start with. So we're going to spin it all the way down to off. And you heard it just beep there. That means it's armed now. So now when we spin it, we can get motor speeds. So here's 1600 all the way up to full speed. Woo, that thing is flying. And back to off. All right, good job today, my friends. That's a very brief introduction to the world of Arduino and spinning a brushless motor. Hopefully you enjoyed learning that bit of code. Make sure that you're thinking about and practicing these different commands because you'll be using them to build your own programs later on to control your ROV. Awesome. Have a great day.